Co-PIs on this are Rafi Mazur from SWRCB, which is the Southern California Coastal Waters Research Project, not the Southern California Wetland Recovery Project or anything like that. And also Andy Wren from Cal Fish and Wildlife. This project actually stems from kind of a pilot project that Rafi did back in 2010 looking at various intermittent streams within the Southern California region. We really liked that work. There were some sites that were picked out in San Diego, so we decided to use swamp regional funds to fund that work, and it's started back in 2013 and it's still going on today. And just a quick side note, my background is actually in marine ecology, marine invert ecology. So if you would have told me 10 years ago that finding water was going to be the biggest issue for my sampling, I would have thought you were nuts. So first things first, I really want to thank all the folks that were involved and are involved in this project, particularly the field crews that go out for Cal Fish and Wildlife, because I think there was a question yesterday, somebody asked about index period for sampling. Well, with these systems, basically the index period gets thrown out the window. So a lot of the field crews, I really appreciate their flexibility and being able to come down and sample, and also my staff having flexibility to do that, because it's tough. And when you get to some of these stream systems after hiking for a couple hours and a couple of miles with all your gear and they're dry, and you turn around and look and where you have to go back out without doing anything, it can be a little tough. I'd also especially like to thank the taxonomists at ABL and Cal State San Marcos, and also the Swamp IQ folks for data management, and Moss Landing folks who used to do that. They're great, and of course SWRCB. So a quick outline, I'm going to give a background on our study design. I'm going to highlight some results to date. Like I said, this project is still ongoing. And then I'll also talk about 3 sites and show you some flow data and scores associated with those sites. So why intermittent streams, or non-perennial streams as I like to call them, or arroyos or washes or swales or whatever you want to call them? Well, in San Diego, they're pretty ubiquitous. Estimates show they make up 70% or more of streams within our region. They're really important ecologically for aquatic and terrestrial organisms. Some folks don't really think about this, but the non-perennial nature actually provides a refuge from a lot of aquatic invasive species, which are perennial dependent. They're really important for fluvial processes. Other research in the literature has shown that of the flow within these systems, 50% or more of that flow actually goes into groundwater recharge, and they have a profound effect on perennial sections downstream. They're also really important for nutrient cycling. And unfortunately in the San Diego region, since there's so many of these streams, a lot of them are actually impacted within developed or rural areas. You'll see in the lower left-hand corner here, a lot of people consider infrastructure to be kind of a flexible term in these systems. I think this picture is kind of funny because this is actually an enforcement case that our board had with someone who put a culvert in, which wasn't working, and every time you would have intermittent flows within this system, it would basically wash out the dirt and the culvert would stay there. So it wasn't working, but they would just come in and put more dirt back in. So obviously this has, when you multiply this across a whole bunch of different areas, this has pretty profound effects downstream. So when we talk about flow and stream systems, people like to classify things, perennial, non-perennial, but really, you know, there's a range of classifications, and this figure comes from one of Rafi's presentations from a year or 2 ago. And really on the left-hand side of the spectrum, you have your wetter perennial streams, and on the right you have your real dry, arid streams that maybe only flow for a few minutes every 5 years or something like that, and you're really lucky if you get to see that. Where I'm talking about is more in the middle section, where you're looking into the semi-permanent or intermittent streams that, you know, only flow for a couple of months throughout the entire year. And really, when you talk about flow in these systems, when you get into the intermittent and ephemeral portions or categories, things get kind of complex because you have lots of different variables and factors involved. You have natural variables like precipitation, whether that's rainfall, snowfall. You have transpiration from riparian. You have geology and groundwater impacts. You also have anthropogenic influences like groundwater extraction, surface flow augmentation, illegal growing operations, things like that. And then it varies throughout time. So I like to kind of refer to this as the stream flow continuum in an ode to prior days. And really my view also is that a lot of the funding has really focused on perennial stream systems and the more semi-permanent systems. And I understand why that has occurred. There's a lot of ancillary species associated with that. But I think it's important to really remember that what happens in these headwater systems and intermittent systems actually really influences these downstream areas. So the purpose of this project was really to determine how far into that dry end of the continuum the existing indices for benthic macroinverts and algae could be used, and how well they worked. And if they didn't, what were the associated, looking at some of the taxa, what was going on here. And really from a regulatory perspective, there's a couple of reasons for this. One is in the San Diego region with so many non-perennial systems, we want to be able to have the methods and tools available to assess the condition of those streams and be able to tell people overall how they're doing. Like I alluded to earlier, there's a lot of permitting and mitigation and restoration that's going on, so we really wanted our permit writers and folks to have the tools available to be able to issue permits and do, assess mitigation sites and things like that. And then Jesse alluded to yesterday, Region 9 is going to be embarking on biological objectives. And back in May, our board directed staff to start working on biological objectives and incorporating them into our basin plan. Right now, we are working on planning for that internally. We expect to start the public process for that probably in the winter or early next year. And we would like to include these systems within biological objectives for our region. And then there's really questions related to, what's our understanding for long-term stream flow dynamics within these systems? Looking at interannual variability, looking at effects of El Nino versus La Nina years, multi-wet years, which we haven't had lately, multi-dry, which we have, and then being able to do predictions and potentially modeling, looking at other predictors such as looking at evapotranspiration index, precipitation index, combined things like that. And then lastly, we do have concerns about climate change and the impacts on these systems, especially given for Southern California the predicted changes in precipitation dynamics. So for this study, we took a reference site approach. We used SWAMP reference to select sites to sample and then evaluate the indices, and then also explore taxa and flow relationships. At sites, we deployed HOBO U20 water level loggers within the streams. These are pressure transducer loggers. They can measure flow permanence and also the variability in flow, which we thought was very important. They're deployed within the actual sampling reaches within these stream systems. Then we visit the sites in spring, and if there is enough water, we sample according to SWAMP SOPs, and we download the logger data. So a little history on the study. Like I mentioned, back in 2010, SWRCB started doing some work in this area. They had 12 sites throughout Southern California, 4 of which were reference. So in spring 2013, we started a pilot deploying some of these loggers and doing sampling at 4 sites to see how it went. And then in the fall of the past couple of years, including this year, we've gradually increased our reference pool. We now have loggers deployed at a total of 43 sites. And here's a map of the sites. In red, you can see an outline of the region. Basically, we have all coastal draining watersheds that from the Mexico border up to San Juan Creek in southern Orange County and the Santa Margarita watershed up in southwestern Riverside County. Sites range in elevation from a couple hundred feet above sea level up over 5,000. And we tried to capture a range of different site characteristics within our choice of 43. So unfortunately, the timing of this, starting in 2013, also coincided with going into the drought. So we did have a challenge in getting a lot of sites sampled. We weren't able to sample as many as we had funded because of the dry conditions. but I'll share some of the results to date from you, or to date with you. So here's a simple box plot of results. We have 49 samples in so far from 2013 and 2014. Granted, this is only 16 sites, so we did some repeat sampling. The y-axis, you have CSEI scores, and then your kind of reference lines there are the statewide reference pool CSEI, 30th and 10th percentiles. The mean CSEI score, surprisingly for these sites, was actually 1, which is, I think, is great. It's very promising. And the 10th and 30th percentiles match up quite well with the statewide reference pool, with the 10th percentile being 0.82 and a little over 0.95, which compares very well statewide for the pool. Results are actually very good for soft algae as well. So this is the box plot showing the soft algal scores at the sites. A few less sites, fewer samples. We had a mean soft algal score of about 81. 10th percentile for us was about 67, which that actually corresponds to the reference pool. A reference pool mean is actually 67, so we got very good soft algal scores. I just got the diatom data. I have not had a chance to look at it. So in the future, would like to look at the diatom data, and also would like to do some taxoflow metrics. So now I'll highlight 3 of the sites and show you some of the flow data that we had recorded and then associated scoring. These sites include Bell Canyon, which is up in Orange County. It's a tributary of San Juan Creek. It's about, I think, around 1,000-foot elevation, maybe 800, something like that. The other site is the upper east fork of the San Luis Rey River at Indian Flats. It's not really a river, it's a non-perennial stream. A little salmonid envy there, I guess, I don't know. That site's about 3,500, 4,000 feet in northeastern San Diego County. And then there's also another site called Carney Canyon, which is east of Escondido near Ramona. So here's what the logger data actually looks like for Bell. On your x-axis, you have date. On the y-axis, you have meters of depth. You can see this logger was first deployed back in April of 2013. Depth was a little over 0.2 meters, and the stream had a good base flow, and then in May started going into what I call an active drying stage and drying out pretty quickly. We went out and sampled in early April when the logger was deployed and went back trying to sample. Here's what it looks like when the logger was deployed. Good CSEI score, 1. Very good soft algal score. Good flows. 6 weeks later, went back, stream is completely dry. And I'll have you note that for the logger deployment here, this stream was dry essentially from May all the way through summer. And then fast forward into 2014, same type of flow figure, date on the x-axis and meters of depth on the y. You'll see there's a little noise around 0. That's all dry condition. But this site ended up being dry from May of 2013 all the way up to the end of February of 2014. We had some pretty big storm events start to come in, roll in then, and you can see the stream started flowing right around the 1st of March. And so crews went out and sampled this in late March, roughly 6 weeks after the logger started picking up flow in the stream system. Got a very good CSEI score, also a very good soft algal score. Roughly 1 month later, went back and resampled this site when the base flow had started to drop and the stream would be in what I would call like a drying stage. You start to see a lot of variability. The CSEI score dropped to about 0.86. Algal score stayed quite high though, which is interesting. Then you can see that the stream flow was non-existent again all the way through until the end of December when we started getting some storm activity. And this site seemed to be more precipitation dependent, and this actual location actually got a lot more, despite the drought, got a lot more precipitation than some other locations. So next site was Indian Flats. It's a sandy granitic site, pretty high elevation, low flow. Here is the flow chart for this site. This site, logger was deployed in November of 2013. It was dry all the way up until March of 2014. Field crews went out and sampled it on the 25th, got a CSCI of 0.83, still within the reference pool distribution, and a very good soft algal score. And the field crew was barely able to sample this site, according to the SOP, but they did meet the requirements, and we calculated that when they sampled, the stream had only been flowing for about 25 days. So the last site I'm going to talk about is Carney Canyon. Picked this site because it's really, I think it's illustrative of one of the sites that's been more affected from what we see by the drought and multi-years of drought. This site was actually a reference site that Rafi picked for his early studies back in 2010, and he did repeat CSCI sampling over the course of from May all the way through the end of June to when this stream dried out in 2010, and found very consistent CSCI scores. They didn't do any algal sampling, so I don't have anything for that. But we thought, okay, this is a great site to pick and keep going here. So it was part of the pilot, and it was first sampled with loggers deployed back in 2013. And you can see kind of tell here in the pictures, on the lower right-hand picture, the flow was actually a little lower than expected. You can see the watermarks on the rocks. Still a very good CSCI score, good flow, good soft algal score, all indicating that the site's reference. Fast forward to 2014. This was sampled in late March of 2014. CSCI score dropped significantly, and I say that without doing stats, but hey, to 0.8. Still a very good soft algal score. Looking at the logger data, though, there was about 25 days of flow. When this site went out to sample, the logger had actually just gone dry. And this stream is really, it was sampled in what I'd call the active drying stage. If you look in the upper left-hand corner, you have disconnections in the stream. You have the stream really is drying out. In the lower right-hand corner, that's the stream flow, that kind of dripping you can see between the rocks there. Fast forward again, 2015, we could not sample the site. It was completely dry. So this site really over time showed effects of lack of precipitation. And this is reflected in the flow data that we had at this site. So you can see here, this site had a logger deployed back in November of 2013, and there really is no sustained period of base flow. You see quick peaks that are associated with storm events. You can see in 2014, when the crew went out to sample then, that there was a little bit of flow, but it wasn't very long. And since then, just some small spikes. So in summary, very excited that the indices are working well to identify reference when there is reference condition. We are seeing a large amount of variability across sites and years, and different sites seem to respond differently, which isn't too surprising. I'm happy to say that other programs, such as PSA and SMC, are incorporating flow loggers into their sampling design. And for 2016, I'm looking forward to the Godzilla El Nino, as someone put it yesterday, and being able to cite being able to sample hopefully some of these sites that have been dry for 2 or 3 years and see how they score out. Also looking forward to doing some flow metric work and some taxa analysis on this data. And that about wraps it up, and I'm happy to take any questions.
Okay, just wanted to clarify that I asked about that index period, and I think your presentation shows why we need the index period. When there has been some sustained flow throughout the system, and that's why we need the index period. And then I was wondering what kind of a sampling method or design you used for the sampling this intermittent ephemeral system, and then have you used have you looked up the EPA publication led by Ken Fritz a few years ago, sampling the intermittent streams.
So in terms of the sampling design, we use targeted reference sites, basically to do the indice evaluation. And we followed the swamp SOP for doing bioassessment in the perennial semi-permanent streams. I will say that for some of the sites this past year, we did push the SOP and we sampled in streams that otherwise probably wouldn't meet SOP requirements, just to see how the scores came out and see if, how it works. I have seen some of the other work in some of the intermittent and real ephemeral stream systems, and we're we've actually allocated funding to explore doing work with things like diatoms in really dry systems.
Thanks, Chad.
Thank you.
Oh, wait.
Thank you for the presentation. I'm intrigued about the life history patterns of the types of taxa that you find there, and where they come from, where they go when it's dry.
So that's a good question. We haven't really evaluated that. Qualitatively, I can tell you that in some of the drier systems, we didn't see very many EPT taxa, but we still got good CSCI scores. I think that's driven more by some of the beetles. Where we did see some of the EPT, I think just from some of the sampling that they're more in like the early stage instars potentially. Now we did see some of these systems had species that can likely take refuge when the streams dry out. So like some Megaloptera type of species were present. Yeah, so they'll actually go into different like wet areas. Yeah, hyporheic areas.